Okay, so we are looking at section 2.8, linear inequalities and absolute value inequalities. And this is an example of a linear inequality in two variables because it has an x and a y. And when we work with linear inequalities, we treat them just like equations except for a few different little things. The first is that we need to remember when we're solving an inequality, we have to flip the inequality when you multiply or divide by a negative. We need to remember that we'll have a solution region, not just one answer. And our line will be dashed or solid. If it's less than or greater than, the line is dashed. And if it's less than or equal to or greater than or equal to, it includes the points on the line, so that is solid. So then, after we graph our line, we want to shade the side that is true, and that is going to be our solution region. And we decide which side is true by picking an easy test point and plugging it into the inequality. So let's look at this example. So the first thing you will do is put the inequality in y equals mx plus b, which this one already is. Y is less than 2x plus 4. And now we can graph it. And we'll graph it by plotting the y-intercept, which is at 4. 1, 2, 3, 4. We put a point there. And then we'll use a slope, which is 2, which means I go up 2 and over 1. Or I could have gone down 2 and to the left 1. And now I can draw my line. I can shoot this through. Alright, so this looks pretty good. And notice that my line here is dashed. And it is dashed because we have a less than without an equal sign, so the line will be dashed. Alright, so now for the shading. We want to shade the point, the side of this line, that all of our solutions will be on. It is a line, so it should have arrowheads. And to do this, you pick an easy point, and 0, 0 is always a very easy point. And you can choose 0, 0 as long as it doesn't fall on the line. 0, 0 is not on the line, so that means that I will plug 0 in for x and 0 in for y, and I want to see if I get a true statement. So if I plug 0 in for y, is less than 2 times 0 plus 4. 0 is less than 4. Well, 0 is less than 4, so that's true. So the side that has 0, 0 on it, right here, is the true side, and that is the side that we would shade. So we shade the side that has 0, 0 because 0, 0 gave us a true statement when we plugged in. And there is our solution to an inequality. So the solution to an inequality in two variables is a graph showing a region where if I pick any point in this shaded region, it will be true in this inequality. All right, the second type of inequality we'll work with is an absolute value inequality. Now, in our previous section, we talked about how to shift absolute value functions. So this is an absolute value function that is shifted left 2 and down 4. So the regular absolute value function looks like, I do want solid lines. Instead of dashed. Right now, just to show the equation. And I'm going to extend it a little further. There's that one. And that one. Let me make it solid. All right, so that's the regular absolute value function. And now we need to shift it left 2 and down 4. So I'll do this in red. I want to take this vertex point and go 1, 2 to the left, and 1, 2, 3, 4. So our vertex is now here, and the slopes are still going to be 1. So I will make a red line solid? It is solid because it is less than or equal to, so it has the equal sign. So now my line there's my right side, and there's my left side. So that's the equation we're looking at, the absolute value of x plus 2 minus 4. So now let's see if I can get rid of, I'll erase the previous absolute value graph, so we just have the one that we're looking at. Okay, so there's our absolute value, and it is solid because it has a less than or equal sign. So it is not dashed, it is solid. And now we want to pick an easy test point, and once again, 0, 0 is not on the line. So let's pick that point and plug it into our inequality and see if we get a true statement. Okay, so when I plug in 0, 0, I get 0 is less than or equal to the absolute value of 0 plus 2 minus 4. The absolute value of 0 plus 2 is 2. Minus 4 is negative 2. So it says 0 is less than or equal to negative 2. Well, 0 is not less than negative 2. It is not equal to negative 2, so this is a false statement. So the side that has the 0, 0 on it is our false side. So that means we have to shade the side of this equation that does not have 0, 0 on it. So we're going to shade below, like this. So that means our solution, if we pick a value, an x, y coordinate, anywhere in this blue shaded region, it should work in this inequality. So if I picked the point 1, 2, 3, 4, 5, negative 1. So let's look at that one. 5, negative 1. I'll plug it in and see if it makes a true statement. So when we plug in the point 5, negative 1, we plug in negative 1 for y, and we plug in 5 for x, and we see what we get. So we have a little typo. Okay, so I fixed that. All right, so when we plug in 5, negative 1, 5 plus 2 is 7. Absolute value of 7 is 7. Minus 4 is 3. And our y value is negative 1. Negative 1 is less than or equal to 3. Well, negative 1 is always less than 3. And with a less than or equal to, only one of the two has to be true. And since negative 1 is less than 3, then this is true. So we tested the point 5, negative 1, which should be in the blue region, and we do get a true statement, showing that our answer makes sense. And please continue on with your homework. You'll have a note sheet in class that's practically identical to this video. And your assignment will be given to you by the substitute. Thanks very much.